I'm Brian, and I'll be doing question 5.
All right, question 5. So this is consider the reaction 3A plus 2B to C. So in this problem here, we actually are given a chart. So I went ahead and just pulled up the chart on this little iPad I got here. So there's that, but it says part I. What is the rate of disappearance of A in a 400 second to 600 second interval? So the rate of disappearance is made by the change in concentration over the change in time. This triangle means delta, which means the change in a value, and it's simply just the final value minus the initial value. So if we're looking at, let's see, rate of disappearance for A, right, from the 400 to 600 second interval. So that's why I put 600 as the final and 400 is initial, and then we're just gonna look at our chart here. So this is A, so all of this is A, we don't have to worry about that specifically. And then we can see 600 seconds, okay, we have 0.109 molar. And then 400 seconds, oh, tap screen, 0.122, okay? So that means this is our final and this is our initial. So we're just gonna come back here. We're just gonna plug that in, final minus initial. We're gonna get a value, and this is in concentration, which is moles over liters, big M. So we're gonna write that unit down here and write the difference between 6 and 400, which is 200 seconds. And then we're gonna divide and then just make sure you convert your units over, and this is the rate of disappearance of A. So from there, we're gonna move into part 2, or double I. What is the rate of the reaction? So from here, you're gonna get the rate of disappearance of A that we found in the last problem. And you're gonna see, because if you actually look at this exponent right here, or not exponents, the coefficient of this letter, you can see that it's 3, so we actually need to divide by 3. And since it's a rate of disappearance that we're using, it's a -3, because it's using up 3 A's to get to C, right? I'll also explain this in another form, which I wrote here later on. But basically, we'll get this, as you can see, this is the exact same thing as what we got here. So just plug it in, and multiplying by 1/3 is the exact same thing mathematically as dividing by 3. And this is your rate of reaction right here. But to explain the 1/3 thing a little bit further, so the rate of disappearance, which is the rate at which A is like consumed or is disappearing from our whole content, our content in the reaction. We mix 3A plus 2B and we get 1C, right? So the rate of disappearance is in milliliters per second, and milliliters is moles over liters, right? So for every 3 moles of A, we undergo 1 mole of the reaction. The reaction does a 1 mole cycle. So that's why I put 1 mole of reaction over 3 moles of A. And since it's disappearance, right, it's negative. So it wouldn't really make sense if our rate of a reaction is negative. We'd be like, oh, wait a minute, unless it gets pretty complicated in here, and this reaction is actually supposed to be reversed. But based on the question and everything, we know that the rate of reaction should not be negative. It's also another giveaway if you don't really understand the conceptual, but yeah, so the rate of disappearance is the rate at which it's leaving, which is why it's negative, and then 3 for the coefficient, and that should also leave you with the answer. Hopefully that makes sense, but yes, I think I further explained that. If not, you can just rewind the video, maybe just go over it again.